Welcome to the Math Record. Today I'll be introducing the power series. So in all our series we've been doing so far, we only found that they either converge or diverge. However, sometimes there are series that only converge when certain conditions are met. This is known as the power series, and they're in the form the summation sk equals 0 to infinity f of k times x minus a, which is just some kind of number, to the power of k. And for power series, there are new things. The first one is radius of convergence. And this is just basically the range at which if we the range at which the summation would converge at. And the next one is the interval convergence, which uses the radius in convergence. And this is where the specific x values that we know that would plug in would make it a converging sequence, a converging series. Let's try a example to understand this. So let's say we have the summation from k, is equal to 1 to infinity, and we want to find it from x to k divided by k times 5 to the power of k. So usually when you do this, you're going to use the ratio test, and the ratio test says that the limit as n approaches infinity, absolute value, when you plug in n, so plug in n plus 1 into k, okay. Now we plug in n into k, so n, and then n times 5 to the power of n. Close your absolute value. Now simplify. So this is just a regular ratio test. So dividing is the same thing as multiplying by its reciprocal. Multiply by n to the power of 5n x to the power of n. X to n plus 1 just makes n. 5n plus 1 cancel out with 5n, so just leave 5. So overall, our limit just simplifies down to x times n, which is xn, and 5 times n plus 1, which is just 5n plus 5. So since the leading coefficients are for both of them are x and 5, and it's only linear, then it just comes out as the absolute value of x over 5. Now we know that the limit, our summation would converge if the ratio test comes out with a limit that is less than 1. So that means the absolute value of x has to be less than 5. And this is known as our radius of convergence. Now, if we want to find our interval convergence, we just need to make this an interval. So that's -5 to 5. Okay, so anything between -5 to 5 will make this a converging sequence. Now, the only thing we're missing are the endpoints. So we need to check -5 and 5 and see which ones work. Sometimes they both work, sometimes they both can work, sometimes they both can't, sometimes only one of them work. So we always have to check. And let's delete that arrow too. So plug in -5 was 1 to infinity. So -5 to the power of k, k times 5 to the power of k. -5 to the power of k can be split up as -1 to the power of k times 5 to the power of k. So 5 to the power of k, 5 to the power of k cancel each other out. So this is just equal to -1 to the power of k divided by k. Well, this is really familiar. This is just the alternating series. Alternating. And the alternating, you gotta check if the limit as n, well, since we're working with k approaches infinity, and ignoring the -1 to the power of k, we have 1 over k. Well, this is definitely 0, so the first condition is met. Second condition, check if 1 over k is decreasing, which it is, because if we increase k, then the 1 over k becomes smaller, so this is decreasing. Thus is non-increasing, so the second condition is met. So that means when we chose x is equal to 5, this is x equals -5, we found that it was converging. So it's negative. And it's converging by the alternating series. Now if we plug in x equals 5, 5 to the power of k divided by k times 5 to the power k. This simplifies down to just 1 over k. And 1 over k is pretty familiar. That's just the p-series. And the p-series says that if p is greater than 1, then it's converging. Well, the power here is to 1, so it's definitely not converging. So this is a diverging. So from here, we do not include that 5. So our actual interval of convergence is -5 to 5, but we include the 5, but not the 5. And the reason is because, as we've shown, the -5 is converging because of an alternating series, and our 5 is diverging from the p-series. In the next video, I will go over power series from geometric series. Thanks for watching.